Bismillahirrahmanirrahim. In Unit 3, we will discuss the fundamental elements of wireless communication system. In this unit, we will discuss block diagram of wireless communication system. We will discuss antenna. We will discuss wireless transmitters, and we will discuss the properties of wireless channel. And finally, we will discuss about wireless receiver. Broadly speaking, wireless system can be classified into well-defined four parts. As we have already discussed. The first part is basically the wireless transmitter. And wireless transmitter is a device that converts the information of data into a highly suitable form for wireless transmission. And similarly, wireless receiver at the another side, another end of the user is a device that captures the wireless signal transmitted by the transmitter, and this transmission is take place with the help of antenna. Antenna is a key component of wireless communication system. It is responsible for the generating of the electromagnetic signal and receiving of the same electromagnetic signal. Obviously, some distortion were taking place, but we will remove this distortion and make it useful for the communication. Wireless channel refer to the specific path or medium through which a wireless signal propagate from the transmitter to the receiver. In next slide, we will briefly discuss each fundamental unit of wireless communication system. A wireless transmitter is a device that convert electrical signal into electromagnetic wave for transmission through the air or space, allowing communication between devices without the need of a physical wired connection. It has following main units: information source, source encoder, channel coder, modulator, and finally demultiplexer. These are the broadly speaking unit of the transmitter. Information source generated data is then transmitted. Information can be generated by either human being as a audio or machine by the electrical signal. But these audio, video, images, or computer output these are the maybe electrical or non-electrical signal, and it can be processed directly into digital communication system. If it is not electrical signal, then transducer is used. A microphone is the example of the transducer, which converts a signal which is a non-electrical quantity into electrical signal. The second building block of a wireless communication system, a wireless transmitter, is a source encoding, which is also called source coding or data compression. They have a different name. The main purpose is to compress the data. The compression is achieved by exploiting statistical redundancies or pattern present in the source signal. There are several source encoding technique, namely as wireless signal processing, such as hump encoding, non-length coding, or arithmetic coding, and maybe many other techniques available in literature. We will discuss these techniques in detail in later units. Third building block of wireless transmitter is the channel coder. The primary purpose of wireless channel coder is to protect the transmitted data against noise present in the wireless channel. And this noise is unwanted signal. You cannot avoid the noise, but you have to manage the noise. There are different type of channel coding technique used in a wireless communication system, including forward error correcting code, automatic repeat request, hybrid request, automatic repeat request, and finally the fourth main unit. Of wireless transmitter is modulator, and the last one is multiplexer. The modulator is an essential component in wireless communication system that convert digital or analog information into formal format which is highly suitable for the transmission over wireless channel, amplitude shift keying, frequency shift keying, phase shift keying, quadrature amplitude shift keying. They are the different type of modulators. And similarly, orthogonal frequency division multiplexing modulators. All these are the different modulators used for modulation purpose. In wireless transmitter, multiplexer is another key component that combined multiple signal or data streams into a single composite signal for transmission over a shared medium. It allows multiple users or resources to share the available bandwidth efficiently. There are few types of multiplexer commonly used in wireless communication: time division multiplexing, frequency division multiplexing, code division multiplexing, and space division and multiplexing are few examples of such multiplexing. And similarly, wireless antenna is another crucial component for wireless communication system that transmits and receives electromagnetic signal wirelessly. It serves as a transducer, as we have already discussed, for transmission and reception. Wireless antenna comes in various types and design, each suitable for a specific application and operating frequencies. Here are some common type of wireless antennas: dipole antenna, which is used for very common example used for Wi-Fi purpose, and similarly Bluetooth. It is also used for the Bluetooth and other short-range wireless application. Patch antenna is a flat planar antenna, which is highly regarded as a radiating element printed on a substrate. It is often found in mobile devices, wireless access points, and GPS receiver. Patch antenna offer a compact form factor and directional radiation pattern. Yagi-Oda antenna, basically commonly known as a Yagi antenna. Yagi antenna are widely used in television reception, point-to-point communication, and long-range wireless link. Parabolic dish antenna. A parabolic dish antenna has a curved parabolic reflectors that focus incoming or outgoing electromagnetic waves to from the central feed element located at the focal point. These antennas are often used in satellite communication, long-range point-to-point links, and audio and radio astronomy. And helical antenna. Helical antenna is a three-point coil-shaped antenna, which with a helical structure, it exhibits circular polarization and is commonly used in applications such as wireless communication system, RFIDs, GPS, and similarly microstrip antenna. Microstrip antenna is another compact antenna, consists of metabolic patch or a strip printed on dielectric substrate. Microstrip antennas are commonly used in portable device, wireless sensors, and satellite communication. A selection of wireless antenna depends on many factors like the required operating frequency, desired coverage pattern, gain, or size constraint, environmental consideration, antenna design, and placement. All these factors play a crucial role in optimizing wireless signal strength, range, and overall system performance. Wireless channel is a medium that electromagnetic signal used to travel. The wireless channel possesses diverse attributes that can impact the transmission of signal. For example, one aspect of the you have to consider is a path loss. Path loss is a reduction in signal power as it travels through the wireless channel. Similarly, multipath fatigue is a phenomenon that occurs when a signal encounters object building, or any other civil structure resulting in reflection, refraction, and scattering. Delay speed is a temporal disparity between the arrival of the primary signal and the multiple reflected signal at the receiver. Similarly, the Doppler effect is also observed when there is a relative motion between the transmitter, receiver, and wireless channel. Noise and interference. The wireless channel experience different form of noise and interference, such as thermal noise and co-channel noise. In wireless communication system, the receiver is responsible for recovering the transmitted information from the received wireless signal, which is generally very weak signal. And some important unit of wireless receiver are listed below, such as diversity combiner. A diversity combiner is used to improve the reliability of the received signal in the presence of fading and multipath propagation. It combines multiple copies of received signal which may take place different paths or experience different fading condition to improve the overall quality of the received signal. Similarly, equalizer is employed to reduce the effect of intersymbol interferences caused by multipath propagation. It compensates the distortion introduced by the channel to recover the original transmitted signal. And equalizer technique include linear equalizer, decision feedback equalizer, and adaptive equalizer. Similarly, demodulator extract the baseband information from the modulated carrier signal. It performs the inverse process of modulation and at the transmitter side, recovering the transmitted symbols or bits. The demodulation being used techniques such as amplitude remodulation, frequency remodulation, or phase remodulation, depending on the remodulation employed. Error decoder is also known as error correction decoder or forward error correction decoder. Is responsible for error detection and correction. It uses the redundancy introduced by the transmitter side to detect and correct error caused by the noise and interference during transmission. Common channel decoding techniques are including Reed-Solomon code, low density parity check, code and convolution codes. And finally, source coder. Source coder is employed in the transmitter data and that has been compressed and encoded into the transmitter. It records the compression and encode data to recover the original source information. Source decoding technique vary depending on the compression or encoding algorithm used such as Huffman coding, arithmetic coding, or transform based coding such as discrete Gaussian transform for image or video data. And finally, the information sink. Information sink represents the destination or endpoint where the decode information is utilized or consumed. It can be display device as a storage system or audio output device, or it may be some representing other way of information, just like as a microphone. These elements work together in the receiver to process the received wireless signal, mitigating channel impairments and recover the original transmitted information for further use of consumption.